Hello everyone. Let us see how to find eigenvalues and eigenvectors of a given matrix. Here I am taking 3 by 3 matrix. First, we need to write characteristic equation, which is nothing but determinant of A minus lambda I equal to 0, where I is a 3 by 3 identity matrix. So let me write what is lambda I here. Lambda I is nothing but, now we need to take determinant of A minus lambda I, which is 3 minus lambda 1 negative 1 1 2 minus lambda 0 1 1 1 minus lambda, and equate the determinant to 0. And if we find the determinant directly and go for computation, it might take time. So to escape that computation, we can use a simple formula here for the characteristic equation of a 3 by 3 matrix, which is lambda cube minus trace of A into lambda square plus sum of the cofactors of the diagonal entries into lambda minus determinant of A equal to 0. For a 3 by 3 matrix, this is the formula for the characteristic equation. And observe the things here. When we start with plus here, we will have minus, plus, minus. Signs will come alternatively. Suppose if you start with minus here, then we will have plus here, minus here, plus here. That is what. Okay. Better you follow only one thing. So let us try to compute what is trace of the given matrix. So here, trace of A is nothing but sum of the diagonal entries, that is 3 plus 2 plus 1, which is 6. And A11 is the cofactor of the first diagonal entry. So that is, you eliminate this column, first column and first row, and take the determinant of the remaining matrix, that is 2 0 1 1. So I need to take the determinant. So the determinant of 2 0 1 1, which is nothing but 2. Let us compute what is A22, that is diagonal of cofactor of the second diagonal entry. So it means eliminate the second row and second column, write the remaining matrix, that 3 minus 1 1 1, and its determinant is 4. And next A4 A2 3 3, which is the cofactor of the third diagonal entry. Eliminate the third column and third row and write determinant of the remaining matrix, which is 6 minus 1 5. And we need to compute determinant of this matrix. It can be easily identified that determinant of A is nothing but 6. Or let us compute. This is 3 into, which is 2 minus 0 minus 1 into 1 minus 0 plus of minus 1 into 1 minus 2, which is nothing but 6 minus 1 plus 1, which is 6. So we got everything. Now we can write the characteristic equation. Therefore, characteristic equation is nothing but lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. We simply substituted everything here, right? Now we need to find roots of this equation. You can use simply calculator or you can directly find. So here the roots are, one root is 1 and the second one is 2 and third one is 3. So roots of this characteristic equation are nothing but eigenvalues. Therefore, eigenvalues here are eigenvalues of a given matrix These are 1, 2, Now we are done with eigenvalues. We need to find eigenvectors corresponding to these eigenvalues. Now let us see how to find. Let us consider the first eigenvalue, that is 1, lambda equal to 1, and let us find the corresponding eigenvector here. So to find it, we need to solve a minus lambda I multiplied with x equal to 0. This linear system we need to solve. So in place of lambda, we are going to substitute 1. It means we need to write what is a minus identity. A minus 1 into I multiplied with x equal to 0. Okay. So if we write this matrix, what is it? Which is 3 minus 1 and 1 minus 1, 1, 2 minus 1, 0, 1, 1, 1 minus 1. And this multiplied with x, y, z equal to 0, 0, 0. And if we simplify this linear system, so we get 2, 1, minus 1, 1, 1, 0, 1, 1, 0 multiplied with x, y, z equal to 0, 0, 0. Now from last two rows are same, and which represents the equation which is x plus y equal to 0. So it says that y equal to minus x. And one more thing, the first equation says that 2x plus y minus z equal to 0. Now you know what is y. Y is nothing but minus x. So let us write it here. So 2x. In place of y, I am writing minus x minus z equal to 0. So from this, we can see z is nothing but minus x. And this will be plus x, not minus. Okay, so we got z equal to x, y equal to minus x. Therefore, what is the solution here? The solution, which is x, y, z, is nothing but, in place of x, we have x only, y is x, minus x, and z is nothing but x. Okay, so now this x can be any real number. Okay, so if you ask me what is the corresponding eigenvector, so in place of x you take any real number, that will give you one eigenvector. So here the eigenvector is nothing but, so the eigenvector is 1 minus 1, 1. Okay, in place of x I substituted 1. Now similarly we need to find the eigenvectors corresponding to the eigenvalue lambda equal to 2. So for which I need to write this linear system a minus 2i multiplied with x equal to 0. So let me write that directly. A minus 2i, which is nothing but 3 minus 2, 1, 1, negative 1. This is 1, 0, 0. And this is 1, 1. And 1 minus 2, that is negative 1. This multiplied with x, y, z equal to 0, 0, 0. And we can observe that the equations here are, the first equation is x plus y minus z equal to 0. And the second one says that x equal to 0, and third one is same as first one. So the second one says x equal to 0. Now let me substitute in this equation. This implies 0 plus y minus z equal to 0. So from this what do I get? Y equal to z. Okay, so therefore solution is going to be here. So let me see what is the solution here. The solution is nothing but x, y, z, which equal to, we got x equal to 0 and y is y, and z equal to what is it we get? Z equal to y. Alright. So therefore one more eigenvector is for lambda equal to 2. One eigenvector for lambda equal to 2 is, which is nothing but 0, 1, 1. Alright. And just we need to find one more eigenvector, that is for the eigenvalue, which is lambda equal to 3. Again we need to solve a minus 3I multiplied with x equal to 0. Now if you see that system, 3 minus 3, we will get 0 here, 1, negative 1, and this is 1, 2 minus 3, negative 1, 0, 1, 1, and we have 1 minus 3, so minus 2. This multiplied with x, y, z equal to 0, 0, 0. Okay, now let us write the equations here. So the equations are nothing but, first equation is 0 into x plus 1 into y into minus z equal to 0. So from this, y equal to z. And from the second equation, what we have is x minus y plus 0 into z equal to 0. Now this implies x equal to y. Okay. And no need to go for the third equation. Why? Because here only two rows are independent. The other row is dependent. Okay. Or okay, you write the other one. The other one says x plus y minus 2z equal to 0. Suppose if you substitute y equal to z, z equal to y, and x equal to y, here what is it? We get y plus y minus 2y, which is becoming 0. Okay, so there is no importance for the third row here. So you can simply forget about it. So let us write the solution here. The solution is nothing but, so what is the solution? X, y, z, which equal to, so we got x equal to y and z equal to y. So in place of y, let us write y as it is. So where y can be any real number. So what is the eigenvector corresponding to the eigenvalue lambda equal to 3? So here eigenvector is nothing but, so you take any number in place of y. So I am taking 1. So if I take 1, 1, 1, 1. Okay. So therefore we got all eigenvalues and all eigenvectors of this matrix. And let us write it as a conclusion. Here eigenvalues are 1, 2, 3, and the corresponding eigenvectors are let us write in an order. For 1 we got 1, negative 1, 1, comma, for 2 0, 1, 1, and for 3 1, 1, 1 respectively. Okay, this is how you can find eigenvalues and eigenvectors for the given matrix. Okay, so I hope you understand this problem. Thank you.